So my name is Fabio. I'm machine learning operations lead at a company called Merantix Labs based in Germany, Berlin, Germany. And I will talk about the way that we integrate Flyte with a library by Facebook AI called Hydra-Core, which is used to parameterize applications. I'll give you like a brief introduction of who we are and what we do and to which requirements this leads for Flyte. And then I have kind of two topics that I want to touch. The first one is that we wanted to be able to very quickly reach continuous delivery for machine learning and give our engineers, even if they don't know a whole lot about infrastructure management, an ability to set that up within a few minutes and then just start using it with Flyte. And then I will talk about how we integrate Hydra to manage workflows with Flyte to execute workflows. And to do that, we built two plugins, one for Flyte to be able to handle the configuration objects by Hydra. And we built one plugin for Hydra to be able to launch Flyte workflows, okay? That's the plan. So let's jump right in. We are a machine learning solutions provider, you could say, in Germany. So we ideate and implement machine learning systems for industry clients in the German-speaking region of Europe. So we have many different projects, and one requirement that comes out of that is that we need to be able to spin up the infrastructure for Flyte very quickly and in many replicas for different clients because they need to be separated. So we cannot have one central instance of Flyte and then run everything in there. We need to be able to start the project and then within like an hour or so have a replica of complete Flyte infrastructure, the dedicated cloud project for that. First requirement. Second requirement, we strive to have everything that happens on the project go through Git. So starting a workflow goes through Git. The results are tracked back in Git. If you want to deploy a machine learning model, that goes through Git. So everything should be in version control. So we want to be able to do continuous delivery for machine learning very quickly and configure it also like with templates within a few minutes. Before we started looking at different orchestration frameworks, we already have integrated Hydra everywhere in our internal stack. So it had to work with Hydra. There was no way around that. And then, yeah, we want the thing to be usable super easily for our engineers. So that's why we built our own launcher for Flyte that I will show you, which lets you register and execute the workflow with a single command. So the way that Flyte currently handles it, I counted it's like 4, 5, or maybe even 6 commands until you can execute something. There's no way I could have convinced my engineers to do that. So we built the way for them that they can just do it with a single command. And we have been in conversations about this for a while. And I also gave a talk about it at a previous community sync. And this is kind of what came out of the thoughts we used to have back then. So maybe let me jump right in and give a brief introduction about continuous delivery for machine learning for those who haven't heard it. This plot here, or this graph here, comes from a really cool article from Google Cloud Architecture Center. Let me give you the very simple idea. Okay, if you have a machine learning system that's not automated at all, you prepare your data manually in one notebook, maybe, then you train your model in another Jupyter notebook, you validate that model, and then you have the model checkpoint, you give it maybe to some other team, and then they deploy it or operationalize it for you, okay? But there are many manual steps involved, and this article explains the different levels of automation in such a system, and the most automated and most mature one is what they call level 2, continuous delivery for ML. And basically the idea is that like data preparation, data validation, model training, model evaluation, model validation, and model deployment, all that gets orchestrated, which, for example, by Flyte or some other framework. So this orchestration of these different tasks here is done by Flyte, and that this orchestrated workflow gets continuously delivered by some CI/CD pipeline. For us, that's Google Cloud built, but it can be any other provider, right? So the idea is you make a change in your repository that defines the workflow, and your CI/CD provider runs tests, and if the tests pass on your workflow, it will register it and run it for you, right? So the only thing you ever do is change code in Git, push it, and it will register and run the workflow for you. And if you set it up in a way that you might even get like a summary in GitHub or something in the PR. So that's the idea, right? You don't manually run a Jupyter notebook and give some file to somebody else. You change code in GitHub, push it, and it runs through until the deployed model. That's kind of the idea of what you see here. And our goal is to be able to do that within like half an hour when a new project starts. So do that super quickly, do it for many different projects at the same time. And what we basically did is that we built a reference implementation of how Flyte infrastructure should look at our company. So in the end, that was a bunch of Terraform files and some Helm values files to customize the Flyte Helm chart. And we have we have an internal templating mechanism that is derived from Ruby on Rails generators, where you have different components and they can call each other. I'm sure one can achieve the same with Cookie Cutter, but basically what an engineer would do when they start their project, they would say MX, the name of our company, generate GCP Flyte infrastructure. The CLI will ask them for a bunch of parameters, like how's the project called, which GCP project do you want to use, and then some other things that are not too important. And then this generator, this GCP Flyte infrastructure generator, will generate some Terraform files that configure buckets for data, EAM roles, so that we can use workload identities with Flyte. And it will generate some YAML files for Flyte. And the engineer just goes Terraform apply, kubectl apply, and then within a few minutes, you go from 0 to a GCP project that has Kubernetes, that has a GKE cluster that runs Flyte, basically. And what they would then do is that they run MX generate Flyte workflow. They give it a name, and then there are some options that are the workflows that we can have. So you can say, do you want Spark or don't I want Spark? And some other things that we say, okay, this is something that we will use all the time. And what this will give you is that it will give you a minimal working example. So maybe the interesting files here are workflow.py that contains a minimal working example of a Flyte workflow. There's a Docker file that can be used to package or to build a Docker image that contains this workflow. And there's some other files that I will get that I will talk about later. For example, these workflow bundle or images bundle here, and then this config folder with other YAML files. That is Hydra stuff. Okay, so what the engineer does, to summarize, is they call one CLI command that will generate them the infrastructure as code to create a cloud project, create a Kubernetes cluster, and then some Kubernetes manifests and Helm chart values file to install Flyte in there. That takes a few minutes. And then they run a second command using this templating mechanism that gives them a workflow with a certain name, and then the option, do I want Spark, do I want the TensorFlow image, and some other stuff. And then that takes like until all the Terraform apply is done and everything's installed. It takes like 20 minutes, I would say. But then they're able to run a new workflow on their own Flyte instance in the cloud that didn't exist half an hour before. Then there is some other generator that will take the information that the user provided and that was serialized to some state file. Like I know this is a lot of code, the details are not important here. What you're seeing here is basically what the user entered as the CLI args. It's saved to some file. And then later when you run another generator, it already knows what you entered. That's the only idea here. And then the user could say, let's generate basically a CI/CD pipeline for feature branches. The command would be mx generate cloud build branch, and with the option register Flyte workflows. And then you would basically, given the name of the workflow that you registered and whether you activated Flyte or PyTorch jobs, etc., it knows what images you need to build. It will build them for you, and it will register the pipelines. So the engineers themselves, they never really need to get into the details of the infrastructure as code or the CI/CD pipeline. They're just given a command line tool where they can generate infrastructure as code. They can generate a minimal working example of a workflow, and they can generate the CI/CD configuration to continuously deliver this workflow. That's the first idea. Now, that brings us into a situation where we can like bootstrap a project very quickly, which is required because we have so many of them that a single instance of Flyte is not enough. But now we are in a position where our engineers can say, I need to start a new project tomorrow, no problem, we'll take half an hour. And then we have Flyte running in that project, which is completely separated from other projects. And now comes the part where it's supposed to be very simple for them to use Flyte, and also with our existing stack, which involves Hydra-Core. Okay. Hydra-Core is a framework developed by Meta AI in Paris by a guy called Omri. I forgot the name, really cool guy though. And they call it the framework for elegantly configuring complex applications. Okay. The idea is that you write YAML files that contain the configuration for your app. So in the simplest case, this could be a conf/config YAML file that has some database configuration. But you can have hierarchical configurations, which means that this YAML file could reference another YAML file. And then when the config is loaded, you have like a tree of different configurations. So the database, it has children, driver, user, path, but there could also be another YAML file loaded in there. So you can have a hierarchy of different configurations, which really lend themselves to configuring workflows, because there could be one config for the entire workflow, and then for every task there is a subtree in that config object. And we use that basically to configure everything we do. Some in-house frameworks for computer vision and NLP, they all use Hydra-Core to parameterize the model training. What's also nice about Hydra, you capture config with schema checks. So said computer vision framework can say, okay, if you want to configure a trainer task, this is and this and this is what we expect in terms of values, and these are the types, and you are warned when you provide values that basically break things. There are launchers for frameworks like Ray or RedSQ, and our thinking was, well, there could be one for Flyte. That's what we built then. And there are nice features like multi-run, which I will show you now. You can also see my terminal, right? Or can you only see? Okay. Maybe let me go back 1 second. So the idea is that you write this YAML file here, config YAML, and then your main entry point function you wrap with a decorator called Hydra main. And here you say, in which folder do I find my config file, which would be this conf folder, and what's the name of the YAML file, which would be config YAML, okay? And then when you execute your Python script, it will parse the config. In this case, it's a single file, but it could be many different files, and it will schema check them and type check them for you. And then it will give this dig config object to your main function here. And this example here will just print it as a YAML file. So when I execute that, I'm just calling Python my app.py. It just prints basically this config object that was parsed from the YAML file. But what I can also do is here I can say multi-run, and now I can, for the database user, provide 3 different values, which is my first name, my middle name, my last name. When I press enter, it will start 3 different executions of the module, where every time the user is a different one. And that's very nice for machine learning when I say, hey, this here runs my training script. This here runs my training script with a whole bunch of different learning rates, and that just spawns different processes and executes them for you. And it would be even nicer if that would work in a Flyte cluster. So this is what I meant with multi-run, with Hydra multi-run. So we did 2 things now. The first thing is that we needed to teach Flyte how to pass these dig config objects that you saw here, which are given to the main entry point, CFG here. We needed to tell Flyte how they could be passed around between tasks. That's the first thing. For that, we built a plugin for FlyteKit. And the second thing is that, like there are plugins for Ray or RedSQ or some other frameworks, we wanted one for Flyte that takes care of building the Docker images, registering the workflow, creating a launch plan, registering the launch plan, and then executing the workflow in the cluster. So we built these 2 things. And the first one, let's talk first about the FlyteKit plugin. Turns out that's super simple to do. I shortened it a little bit, but it's in principle what you see in the green boxes here is the code we wrote for that, which is really nice. So we rewrote the dig config transformer plugin that inherits from the type transformer. And whenever we use a dig config to like as an input to a task or as a return value from a task, this class here gets invoked to either convert a dig config object to a literal. And in the end, the only thing it will do is it will use the like omega conf, which underlies Hydra, to convert the configuration object to some JSON container, to some simple JSON, or load it from this serialized value back to a config object. So with that, Flyte all of a sudden can pass these dict-config objects from Hydra around, which is super nice. And our minimal working example that you get when you render this template, it might look like this here. So the pipeline, it gets like a config object. The evaluator task gets a config object. The train task gets a config object. So everything is config objects now. And as long as the config object doesn't change, the caching kicks in and the task is not run again. But if one of the values in these YAML files change, all of a sudden you need to run the task again. The way we do it is that typically we first have a create config task that takes this giant config object, which has like one subtree for the evaluator in this case and one for the trainer, and we split these out and then return them and pass them on to the other tasks. The reason we do it this way is that in the workflow here, these things that are returned, they're actually promise objects. So you couldn't go config dot some subtree, that wouldn't work. But starting a pod for that is actually super simple, which it works really well for us. It also uses caching. So if this giant config object didn't change, the first task will realize that. Because we use the struct type from protobuf in the Flyte UI, you can actually see the config object like a nested JSON here. Super nice. You can manually load the launch plan here and then change the learning rate, click launch, and it will launch the execution with the changed learning rate. So it's very nice that we can also visually inspect this config object and change it here. So that's really cool. Now comes the fun part for us, because when we looked at different frameworks for orchestrating machine learning workflows, we immediately liked Flyte the most from all options like Kubeflow pipelines or Perfect and all the other ones, because it interacts really well with Spark, but also the guys from Weaveworks said, and also because it integrates the distributed training with PyTorch and TensorFlow jobs so nicely. So that was like perfect. We can run Spark and then distributed training in one workflow. We love it. And then we said, okay, but we want to execute it with a single command so that it's very simple to use for data scientists. And what we in the end settled on is saying, okay, if I run Python workflow.py, I want to execute it locally. If I run Python workflow.py -m Hydra launcher equals to Flyte, I want the Flyte launcher to build the Docker images. I want it to register the tasks, and I want the launcher to execute them in the cloud. And if I run Python workflow.py Hydra launcher equals to Flyte, and then specify 3 values for the learning rate, they don't make sense here. That's dummy, of course. But if I specify 3 values for learning rate and 2 values for some other parameter, I want the thing to do the auto product, 6 configurations. I wanted to build the Docker images, register the task and the workflow, and then start 6 executions in the cloud. That's kind of what I want to do, right? And I will now give you a brief overview of how that works under the hood, because I'm really happy with how that turned out. And maybe there's also some of these ideas can be taken also to FlyteKit, and maybe there could be a way there too to automatically build images and register everything. So let's look at this Hydra main decorator here and the workflow decorator. So we have a pipeline that is decorated with workflow, and it gets a config object, the config object. So this here is a Flyte pipeline, right? And it is configured using this Hydra config object. And then there is if name is equals to main, and that here will call just a function that is decorated with Hydra main, and it calls the pipeline. So when the user executes Python workflow.py, first we go into this if statement here because this is main, so we call main, and then the Hydra decorator kicks in. It goes to this directory, parses this workflow bundle YAML file containing the configuration. It gives us a config object with this parse config, and then it calls the pipeline and passes this keyword argument here. That's when you would do it locally. Now, when we say -m Hydra launcher Flyte, the same thing happens. We first go to the main. It invokes the decorator. It parses the config object, but then it never reaches this line here. So we never call the pipeline locally, but we will go to the Flyte launcher class. Okay, so that's the difference. When we don't specify this launcher here, we would call the pipeline here with the config object. If we do, the decorator is still invoked here. It still parses the config, but now all of a sudden we are in the launcher, in the Flyte launcher. This is the difference between this file here, or this command here, where we don't specify the launcher. we actually parse the config object and give it to the pipeline locally. And if we specify the launcher, we still parse the config object, but then we go to the launcher code. Okay. And what the launcher code will do, I hope that you can see it. I'll make it a little bit bigger. It's actually very simple. There's some module called image builder, and it builds a Docker image. And the information for how this Docker image should be built is in the config object, which here is called self.config. That's basically the past config object. So it contains the information where the Docker file lies. It contains the information where the Docker context should be in the repository. It contains the information how the image should be tagged. It will push the image. It figures out the version of the pipeline, which depends on whether you are in a feature branch or in main. It will check for you if there are uncommitted files in your repository, and it will append a dirty suffix to your workflow version so that you know that this wasn't a clean Git commit. It will check in your configuration if there are any extra images, and if there are extra images like a Spark image or some TensorFlow image, it will build them for those. It will build these for you too. And then it will create a Flyte remote object for you that uses the image tag that we built here and all these extra images that we built. It will open a temporary port forward into the cluster, so you don't even need to expose Flyte into the internet, which is something we don't do typically when the project lasts for 4 weeks and we need to start very quickly. So for us, we kind of use the hack to start the temporary port forward into the cluster. The config object contains the information which module contains our workflow, and we will extract all tasks and workflows from there. And then using this remote, we just register them. And we create the launch plan that registers the self.config as the config and the workflow. And then we start an execution, or if there were like these multiple overrides were passed as a command line argument, we will start n executions using different config objects. That's kind of how it works. So if you run it locally, it parses the config from the YAML file and gives it to the pipeline. If you specify the launcher, it will still execute this Hydra decorator and pass the config object, but then it will never actually call the pipeline locally, but it will go into this launch method of the launcher. There it will use the config object to figure out how to build the main image of the workflow. It will figure out whether there are other images that need to be built for your workflow. It will open a temporary port forward into the cluster and register the tasks and workflow that are basically specified in this module with these images, and then it will start an execution. And now our engineers typically, when they're in development, they go Python workflow.py locally, and then when they're happy to say, okay, this can go into the cluster, they just specify this here. That by default registers everything in the development domain. And when they do git add workflow.py git commit, then they can specify in parentheses train, and then the CI/CD pipeline will do the exact same thing. It will build the images, it will give them to Hydra, and then if you specify train in your commit messages, it will actually kick it off, and then it will train. So that's the way that we reach our goal of being able to have a single command, and that is the difference from running it locally and running it in the cloud. That's how we solved that. We are using it in the first projects now, so in a few weeks we will have feedback whether people like it, but at least I'm pretty hyped about it. So I think time is almost up. Don't want to take more of your time, but let me quickly summarize what I talked about. So the first part, which is kind of decoupled from the second part, I talked about our engineers start when they work on a new project, how they reach a Flyte, like a cloud infrastructure with Flyte, where they can do continuous delivery for machine learning within a few minutes. So go from git commit, it automatically runs the execution for you and sends you a summary to your PR. And for that, we basically have a reference setup that is templated using Jinja templates, and we have some custom templating mechanism that allows people to render that, but you could do the same with cookie cutter. Then we have a standardized way of parameterizing Flyte workflows where the workflow is given one config object from Hydra, and every task in the workflow has its own subtree in that config object that is given to that task. And the template, or the caching mechanism will figure out whether the entire thing changed or only like parts of it changed. And there's a Flyte launcher that When triggered, we'll build the images for us. We'll register the workflow using these images, and we'll start an execution with a single command. So you write Python workflow.py, it runs locally. You write Python workflow.py Hydra launcher equals to Flyte, and it will automatically transfer it into the cloud for you. But still work in progress for us. We're currently exploring a way that we can put hyperparameter optimization into that. So what we want is that there's some meta workflow that has one pod that starts executions with different config objects of the actual workflow. And we are currently exploring how we can prune away runs that we already know are not going too great. So we're exploring how we will incorporate that into the stack. And I think the interesting question for me is whether maybe not the integration with Hydra, because that's, I think, custom to us and of course absolutely optional. But I think this way of specifying in a config file what the image tag should be, what the context should be, and what the name in Flyte should be, and then with one command saying run. I think I'm interested in having a discussion of how this could be done by Flyte, because I think this is interesting for many people, and really lowers the entry barrier. If it's just a single command and in the config file, the information is stored of how the images should be built. And basically the idea would be to refactor away this build and this build and push bash script that is currently in the template, in the FlyteKit template, and replace it by the configuration file where it says, okay, these are the images, these are the names, the tags, and the context, Docker context, FlyteKit run, I don't know. And it just does it for you. That would be the idea. Do you have any questions?
Yeah. This is outstanding work. This is amazing, Fabio. And actually, you've really distilled the problem nicely. So extremely grateful. But I'll ask anybody has any questions, comments. I have a couple, but I'll wait.
I have a quick question, Fabio. Is the launcher a Hydra concept, or is it custom to this setup?
No, it's a Hydra concept. So there are launchers for Ray, for AWS Batch, and these are all like custom plugins that people wrote for Hydra. There's an abstract base class where you implement the launch method. The launch method is given the config object that Hydra parses for you, and then you take it from there. And we figured that makes sense. We use Hydra. We want to use Flyte. Let's build the launcher for it, where we put all this logic of how the images are built into the launch method, and then use the Flyte remote to say this is what we want to register and execute.
Gotcha. And then invoking the workflows script with that -m Hydra launcher flag, that'll also actually execute the thing on the cluster, right? So it'll do like pretty much everything plus actually running it.
Yes. So the way, there is in Flyte, there's one, or then the launcher, the way we built it, there's a launch plan config object that's just some data class, and there's a run attribute that is set to true by default. And then you could say Python workflow.py -m launcher equals to Flyte, and then you could overwrite and set it to false if you want. Then it wouldn't execute. And the way that the CI/CD pipelines are built is that actually whether we say true or false there depends on the commit message. So if the commit message doesn't, like the trainings we do, typically they run for hours, so we really don't want every commit message to trigger that. So if in parentheses or brackets train is in your commit message, it will set that value within Hydra override to true, and if it doesn't, it will set it to false. So by default, when you run it locally, it will always execute. But you can, with an override, Hydra override, set that to false, and in CI/CD it will depend on what your commit message is.
Gotcha. Cool. Thanks.
It's pretty cool. Yeah, actually, in today's 2 sessions, there was one with Bazel, the other one was with Hydra. So we see that everybody wants to go from like 0 to 60, and yes, we completely get it. You should. And so what, Fabio, do you have any plans in upstreaming Hydra launcher into Hydra-Core, and as well as the dict config into FlyteKit?
If there's interest, we definitely would do that. Yeah. So if people say, hey, that we would like to use that too, then we're absolutely happy to contribute that. Yes, definitely. Yeah, I'm not sure if people would want to have the temporary proxy, the port forward, if that's something that should be in the default version. I feel like it's probably something that we use internally, but it's still a hack that kind of feels wrong. It's rather convenient if you don't want to exploit your cluster into the internet.
Yes.
But still, yeah, I'm not sure if that part, maybe we would take that part out. But in general, I think we're very happy to contribute that to Hydra and to Flyte.
Oh yeah, that will be amazing. I think Jeev has a question. Is it possible to launch with Hydra via notebooks? You
no.
could, right? You could convert NBDev, which is also within that.
So the assumption for Hydra is that there's one function in the module that you call that you decorate with Hydra main. And I don't think that, let's say it's not the idea to use it in a notebook. Maybe you can get it to work. Probably you can get it to work. But the idea is that you have a module and there's like a main function and you decorate it with Hydra main. That's kind of the idea of it.
Yeah. Jeev, to answer your question, so I'm working on updating Flyte config in a way and Flyte remote. So you can now call it in a functional way. So that means we can say Flyte.register, or we can add a new function called Flyte.deploy that builds the container and pushes. But I think the deploy, because of the variety of Hydra and Bazel, and then everybody can extend it potentially. I think that belongs really outside of Flyte remote. But as add-ons, right? You can have plugins. You can do pip install XYZ, like Jupyter deploy kind of thing, of Jupyter deploy, and that should give you. And the way I was thinking about this, Jeev, I don't know if you've thought about it, is that we could use fast register, but use pickle to register files and put it in the container, and essentially use a pickle resolver to resolve from that loaded file to run at runtime. And it's possible then to go from Jupyter notebooks to an execution. I still don't know if you should do it, but I'm not going to be a person who's going to be like, hey, you should be pedantic about this. It can't be. There are different setups and folks have different preferences. But Jeev, do you have any ideas?
Yeah, yeah. So we've been, sorry, can you hear me?
Yes.
Okay, yeah. So there's a couple of things we were thinking about. I love this Hydra idea. Some of the concepts are really amazing, and I think they fit within the way that Freenome works. But then some of it is also, is a change from how we're working right now. I think that being able to launch workflows from either scripts or Jupyter notebooks would be like a first step, because that gives us a lot of power about actually being able to correctly specify inputs and things like that, without having to users write either YAML files or somehow write their inputs into CLI strings and stuff like that. So that's like the first step. The second step, I think that would be really nice, although not super necessary, would be to have users kind of work entirely in notebooks and just write their tasks and workflows, maybe specify like a base image, and then have those tasks and notebooks run within the base image. So that's something that it's in our roadmap, but we're not really pushing a lot of resources behind that. But I think the first one, at least, just being able to go from say you're working on a workflow project, so just doing an init, creating a project, writing some changes to the workflows, and then just pointing to that directory and doing a run or a build, right? Where some business logic can come in and basically do exactly what the launcher stuff is doing that Fabio presented, which would build and push. It's either doing it locally via the Docker, or it's doing it on the cloud via Google Cloud Build, or literally anything that you want, Knative or anything. And yeah, once we have that, then users don't have to worry about all this stuff, right? They don't have to go and do the build. They don't have to go and do the register. All they're doing is editing code, and then basically in the directory, executing the workflow. So we want to get there. I think that's one of the big pieces that's slowing us down a little bit. But I think this presentation gives us some really good ideas to move forward on that. Thank you.
Yeah, I think I would love to partner on this. I think what we are working on in the core, basically exposing and making it absolutely easy to build this on top. And I think then just like Hydra plugin, we should probably add Google Cloud Build plugin. We'll have to do that, right? Because again, is what I've realized already is that somebody's using Bazel, somebody's using Google Cloud Build, somebody's using Docker, somebody's using BuildKit, somebody. So there is just no way to standardize on this stuff. And I get it, right? You know, DevOps is like a big area, and people are changing all the time. But we don't want to dictate anything over there, but we want to make it absolutely easy. And I think the Bazel project by Woven Planet is also open source now under Flyte.org. Is that right, Versha? Miguel, you guys have not, we have not marketed it, but is it going to be open source? Did we lose them? Maybe they had to drop off. Yeah, but it's supposed to be open source, and I think Stripe is also using it. So we can talk more about like how do we create a nice interface across all of these things. I would love to do that, Fabio. Any suggestions from you? Like, love what you've done. So thank you.
I mean, I totally understand that the Hydra stuff is kind of optional with the plugin, but it will never be. It's absolutely clear it will never be part of it. I think what would be, at least what I think would be helpful, is whether the configuration of how the images should be built, meaning where's the Docker file, what's the tag that's supposed to be used, and what's the context. It would be nice if there was a default way that this should be serialized in the Flyte config. And then given that, FlyteKit should have a way, if a Docker daemon is available, to build them for you. And if you are in an environment where there isn't a Docker daemon available, like in CI/CD, like that's sometimes the case, right? Or if it runs in the Kubernetes cluster, you need to use Canico and stuff like that. At least then people can say, okay, we use this and this CI/CD provider that you probably will never integrate with, which is totally like what you should do. But then people can say, okay, this is how the images should be built. We'll build them for you and give you the resulting tags, basically, right? And that will then fit in what we do with Hydra and what the people at Weaveworks do with Bazel, by building the images outside and then passing them to Flyte, I guess. But if the Flyte config contained information on how the images should be built, then it could do it when there is a Docker daemon. It could do it for you. And if there isn't, then at least the information is somewhere, and you can parse it and convert that into some CI/CD pipeline yourself, and then give FlyteKit the resulting image tags. That would be, I think, super helpful.
Yeah, the way I've been thinking about it is essentially the API says, give me a config object which includes the image that was built in the core. This is the core API, and it just does everything for you from that point on. And then we create one more layer up, which is essentially where this is the default one. Let's say the Docker deploy, which means it builds from Docker and deploys. And I think that can be done. I think so.
Are there other questions?
Jeev wants to provide a service for building and registering containers and workflows. Jeev, I'm waiting for your contribution, man.
No, I was just kind of like talking out loud. Maybe we talked about this like a long time ago, where we can totally build images in the cluster itself. So yeah, I mean, it's still sounds pretty premium to me, but we'll get there.
This is a community thing. This has nothing to do with unions itself. But cool. This is great work. And Fabio, if you need help in upstreaming, and if you can upstream, we would be extremely grateful. On the upstreaming side, the Gojek team is upstreaming DBT plugin. So that should be coming soon. And one other team is upstreaming something missing. Sorry, I will bring it. But yeah, lots of stuff happening. So thank you for everybody, for contributing and making such a wonderful community. But yeah, we are well over time. We should stop. All right, guys.
Bye.
Thank you again for all the presenters. See you guys again in 2 weeks. Bye.
See you.
Thanks all.